Hi friends, this video we are going to see about gradient of a scalar point function. Scalar point function means nothing but each point in the domain we allotted a some scalar value, that is called scalar point function. That field is called scalar value, scalar field. Okay, example of the scalar field is temperature is the scalar value and pressure is the scalar value. Okay, so example of the scalar value is temperature, and let f of x comma y comma z be a scalar valued function. Scalar value, scalar point function. We assume that scalar point function, that is the correct term. Scalar point function. Now on region R, for a region R. So I assume that let f be a scalar point function on the region R. Now next is I am going to talk about what is the level surface. Suppose I take it as f of x comma y comma z equal to c. Here c is the constant. So then it's only a z is the independent variable, it's dependent variable, x and y are independent variable. You can write it as, so you can form the some surfaces. That is, if you are changing the c, you will get the family of surfaces. So it constitutes a family of surfaces. These surfaces known as level surface. Level surface. So I will find that. So I got the one scalar point function on R, and then I equal to some c. It will get us some surfaces. These surfaces is called level surfaces. Now I am going to define a del operator. So del operator defined as, so this is the Greek letter del. Operator is defined as, it's a I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z. Correct? So is called the vector differential operator. Del or nabla. Okay, so this is the operator we filled that, and suppose I already said that, so del f become, so it's a vector quantity, so some people they cast as a vector also they will ignore, otherwise simply denote as a del. This both are same, fine only. So del f equal to, suppose f is a scalar valued function, but we get it as dou f by dou x I cap plus dou f by dou y plus j cap dou f by dou z times k cap. This is called gradient of a scalar point function. This is known as the gradient of scalar point function for a region R. Okay, so this is the gradient. So gradient is nothing but this is if you want to take the partial derivative with respect to x times I cap plus partial derivative with respect to y times j cap plus partial derivative with respect to ez and k cap. So what is the geometrically means? Okay, so we are giving something. What is the geometrical meaning? Okay, now so f of x comma y comma z equal to surface. Now you take it. We know that level surface, that is f of x comma y comma c is the level surface. So I will take some curve or arbitrary curve. I take it. So it is then each point it's suppose I take the curve r vector of t in a level surface. Level surface, that is we take it as f of x comma y comma z equal to some c1. I fixed it. Okay, then it's a position vector of the level surface. I will take it. Next I will take it that this is my level surface. I will take the d. So now here r of t is defined as r of t is nothing but x of t I cap plus y of t times j cap plus z of t times k cap. So your input variables are only t. That is t is the only independent variable. X and y and z are dependent variables. So that way only the curve you are seeing. So we are writing the parametric from the curve r of t vectors. Okay. Now this is basically a question vector. If you are choosing your particular point, it will give like that. Okay. Now so then this curve I can write it in the level surface because r of t is in the level surface. So I can write it f of x of t comma y of t comma z of t. Correct? Suppose I have the surface on this line, I can take it this way. Correct? Equal to c1. I know now I want to take the derivative on both sides. So what is df by dt equal to 0 because I take the both side. This is a constant. I already know that c1 is a constant. I take the derivative with respect to time t, it becomes 0. Next, so now I want to evaluate the df by dt. So I know that is a total derivative formula. This is left hand side. What will comes? Dou f by dou x times dx by dt plus dou f by dou y times dy by dt plus dou f by dou z times dz by dt equal to because from my right hand side is 0. So this guy is 0. So I can rewrite this guy as dou f by dou x I cap plus dou f by dou y j cap plus dou f by dou z k cap with dot product is what I can take it as dx by dt I cap plus dy by dt j cap dz by dt k cap equal to 0, correct? Now you look, this is the first term, this guy is nothing but your gradient of f, correct? So this is the some curve. I want to take the derivative with respect to time. It is a some tangent. So tangent vector. So gradient f vector dot t vector equal to 0. So it's not a t cap, so t vector. T is a tangent vector. This implies. So this meaning is the gradient f is orthogonal to tangent vector. So this implies gradient f is normal to the curve r of t. But you look here, what I take it, r of t is a, I am choosing, r of t is not a fixed one, r of t is a arbitrary curve. So this implies any curve in the level surface f of x comma y comma c is perpendicular. So this implies the gradient f is normal to the surface f of x comma y comma z equal to c1. So not only the c1, you can change any gradient of c. It becomes any, if you change the different of surface also, the gradient f is always normal. Okay. So this video we are giving the geometric meaning of the gradient. Thank you for watching this video. If you suppose you like this video, please share with your friends.